children, welcome to our physics class. In previous classes, we have gained some knowledge on displacement, speed and velocity. But in today's class, we shall gain some knowledge on some important and exciting topic of kinematics, that is acceleration. So here we go with acceleration. Children, what is acceleration? Yes, acceleration means the increase in velocity per unit time or decrease in velocity per unit time is generally referred as acceleration or deceleration. Children, have you ever wondered why whenever a car is being started, so as and when it is moving on, it accelerates, its velocity gradually increases. But whenever the brakes are being applied, its velocity gradually decreases. Isn't it, children? So this increase in velocity per unit time is called as acceleration, whereas the decrease in velocity per unit time is called as deceleration. The other name for deceleration is also retardation. Okay, children. So, what is acceleration? The increase in velocity per unit time is called as acceleration, whereas the decrease in velocity per unit time is called as deceleration. So, negative acceleration itself is called as deceleration or retardation. Negative acceleration is called as deceleration or retardation. Okay, children. So, mathematical form of acceleration, that is the total change in velocity. I repeat, the total change in velocity of a body to that of the total change in time or total time taken to bring that change is called as acceleration. So, let us try to represent the same. Okay, children. So, what is acceleration? Acceleration. Acceleration is nothing but increase in velocity. Increase in velocity per unit time. Per unit time. Similarly, you have one more thing called deceleration. So, what is deceleration, children? Decrease in velocity. Decrease in velocity per unit time is defined as your acceleration. Here it is increasing and here it is decreasing. So, clearly, this acceleration and deceleration are opposite. So, no doubt that, so negative acceleration, if it is mean reversed, the negative acceleration is also called as your, deceleration. Negative acceleration is also known as deceleration, or another name is also there, that is retardation. What is that, children? Deceleration or retardation. And now, if we try to discuss something regarding the mathematical form of this acceleration, then mathematical form. What is the mathematical form, children? So, as we have discussed just now, that the total change in acceleration is nothing but the total change in velocity. What is that, children? Total change in velocity to the total time taken. Total time taken for that change in velocity. Time taken for that change in velocity. So what is the mathematical form of acceleration, children? The total change in velocity to that of the total time taken to bring that change. This ratio itself is called as your acceleration. Children, again, this acceleration we classified into two types. One is uniform acceleration, the other is non-uniform acceleration. Suppose if this ratio is constant throughout its motion, then we say that it is moving with uniform acceleration. But if this ratio will be changing continuously time to time, then we say that it is moving with non-uniform acceleration. That means, what is uniform acceleration, children? Acceleration is again classified into two types. One is uniform acceleration, the other is non-uniform acceleration. Uniform acceleration and other is non-uniform acceleration. What makes the difference? If this acceleration of the body is constant throughout the motion, that is, change in velocity per unit time always constant. Every moment, if it is increases with the same ratio, 3 meter per second square, 3 meter per second square, 3 meter per second square, and so on. But in that case, it is moving with uniform acceleration. Suppose in another example, if we consider, earlier it moved with 3 meter per second square, then it changed, it reduced its speed and 2 meter per second square, again 6 meter per second square, lot of increase is there, again 10 meter per second square, some difference is there, fluctuating changes are there. No doubt velocity will be increasing per unit time, but not in an equal ratio, varies, okay. So whenever this acceleration, change in velocity per unit time is constant throughout the motion, it is said to be uniform acceleration. Whereas if the acceleration of a body changes with respect to changes means, then it is said to be as non-uniform acceleration. So hope you understood, children. So let us try to discuss in detail based on the some numerical part. First question in worksheet number 4, a body can't have a constant speed and varying velocity. Let us discuss in detail. For this, let us consider a body moving with in uniform circular motion. So let us suppose a body is moving in a uniform circular motion. Whenever a body is moving in this motion, let us suppose that the position of the body be here, and let us say that the body is moving with some constant speed, say 5 meter per second. As the body is moving with constant speed, if the body reaches at this position, then also we have the speed as 5 meter per second. Here also 5 meter per second. Here also 5 meter per second. Throughout the motion in a circular motion, the speed is only 5 meter per second. But if you consider its direction, the direction is always given by the tangent drawn to the circle. So it is directed in this direction. Tangent drawn here in this. Tangent drawn here, here. Tangent drawn here. Every position, its direction changes. Okay. So if you discuss something regarding the velocity, then though speed is constant, velocity is nothing but magnitude. Velocity is a vector quantity, has magnitude as well as direction. So magnitude part is nothing but speed, and speed with the direction gives you velocity. So I can write down that velocity equals to speed plus direction. Just now we have discussed that the speed is constant throughout its motion. It moves with only 5 meter per second. So speed is constant speed. But as the direction is changing, so velocity changes. Okay, so velocity changes, varying velocity. So a body can have a constant speed and changing velocity. Varying velocity is nothing but changing velocity, because if direction changes, velocity changes. So it can have a constant speed and varying velocity. Hence, this statement is not possible. A body can have a constant speed and varying velocity. But what it was given, not can't, they gave it as can't. Hence, the statement is false. Moving to the next concept, that is acceleration and a constant speed. As long as the body is moving in the uniform circular motion, it is having some constant speed. This example which I have considered 5 meters per second. But if you discuss something regarding its acceleration, acceleration is something acting on it is centripetal acceleration, wherever the position of the body be, but its acceleration always acts towards the center. Centripetal acceleration here means towards the center, here, whatever, centripetal acceleration. So though the body is moving with constant speed, say 5 meters per second, this body possesses centripetal acceleration. So a body can have a constant speed and centripetal acceleration. This statement is also true. This statement is also true. But what they have said, a body, what we know is a body can have constant speed and acceleration. But what they gave was can't have. So this also we can't consider. So moving to the fourth example, non-zero speed and zero acceleration. Let us suppose that a body is moving uniformly with some speed. Uniformly with some speed. As long as the body is moving uniformly with some speed is there, non-zero speed, some speed is there, okay, and zero acceleration. So zero acceleration means as long as the body is moving with some speed, that means constant speed, okay, in some direction, in particular direction, constant speed and direction. Okay, children, in that case, we can say that velocity is there, okay. Even the velocity is there, but as it is moving with constant velocity, then it has zero acceleration. Okay, children. So, a body can have non-zero speed and zero acceleration if it is moving with constant velocity in particular direction, unique direction. So, but what they have, it can have, but they state that it can't have. So even we also can't consider this. Now moving to the third one, a body can't have constant velocity and varying speed. Children, just now we have discussed that velocity is nothing but speed plus direction. Okay, children, if speed changes, velocity must change. Either direction changes, velocity changes, or speed changes, velocity changes. But what we had said is speed is constant and velocity changes. It is a contradiction. It can never happen. Okay, so a body can't have constant velocity and varying speed. So you're absolutely what he said was true. The body can never have a constant velocity and varying speed. Speed is changing means velocity must also change. So what is your correct option? Third option is your correct option, because a body can't have constant velocity and varying speed. The others, a body can't. A body, I'm replacing this can't with can, okay. A body can have a constant speed and varying velocity. A body can have acceleration and a constant speed. A body can have non-zero speed and zero acceleration. Whereas a body can't have constant velocity and varying speed. So try checking the answer in the reverse way to get you more clarity. Moving to the next question, children. Which of the following changes when a particle is moving with uniform velocity? Children, whenever a body is moving with uniform velocity, then time to time what happens is position changes. Position changes from place to place, and earlier one position, next. Whether it is moving in a circular motion or a straight line motion, its position continuously changes whenever a body is moving with uniform velocity. Okay, so uniform velocity means constant velocity, because speed remains constant. Velocity, uniform velocity means constant velocity. So why does velocity changes? It is constant. The name itself indicates acceleration. So whenever a body is moving with uniform velocity, constant velocity, no acceleration. Acceleration is zero because there is no change in velocity. Earlier I defined acceleration as change in velocity by time. Change in velocity upon time. But Here no change. Uniform velocity means there is no change. Constant velocity. Initial, final, both velocity remains constant. This is 0. 0 by time is 0. So there is no acceleration. Okay, children. Hence, which of the following changes when a particle moving? So definitely its position changes. Hence your answer is first option. Moving to the next question. The correct statement from the following is a body having 0 velocity will not necessarily have 0 acceleration. Yes, children. Let us suppose a body moving with 0 velocity. So no change in velocity. Then acceleration will not necessarily have 0 acceleration. So again you can consider for this let us consider a ball thrown upwards. A ball thrown upwards somewhere like this. At the highest position, whenever the ball reaches the highest position, so as long as the ball having velocity goes up, and at the final position when no velocity is there, then again what happens, because the gravitational pull, it again falls down. So at the highest point of a vertically thrown body, velocity is 0. But even then, as the gravity is pulling it downwards, acceleration due to gravity acts on the body. So, vertically thrown body or ball, vertically projected ball, at the highest point velocity is 0, but acceleration due to gravity acts on it. So, what they said, correct statement, a body having 0 velocity will not necessarily have 0 acceleration. This was the example, highest point velocity is 0, but acceleration is not 0. Hence, this statement is true. Let us check for the other options. Body having 0 velocity will never necessarily have 0 acceleration. This is a contradictory statement for that. If this happens to be true, this happens to be false. A body having non-uniform velocity will have 0 acceleration. Non-uniform velocity means as the velocity is changing continuously time to time, definitely the body may be accelerating. So this statement is uniform velocity. Body having non-uniform velocity will have 0 acceleration. How can it have? It has some acceleration, because as change in velocity is there, whenever the velocity is changing, acceleration acts. So this statement is also false. A body having uniform speed can have only uniform acceleration. Who said? Consider the example of the circular motion. In that circular motion, a body moving with uniform speed, but have uniform acceleration? No, it may not have uniform acceleration, maybe non-uniform. Okay, that is centripetal acceleration, something it might be having. So this is also wrong statement. What is the correct statement, children? First option is your correct option. Next, choose the wrong statement. Yes, retardation. Retardation is nothing but negative acceleration. If the velocity is increasing gradually, it is called acceleration. If the velocity is decreasing gradually, it is called as deceleration. So, deceleration or retardation, any name, is a vector quantity. Yes, of course, it has direction. Okay. Well, so velocity is a vector quantity, acceleration is also vector quantity. Hence, retardation is also vector quantity. Consider that example of ball only. Upward motion, negative acceleration. Downward motion, positive acceleration. Like that. Okay. Acceleration due to gravity is a vector quantity. Of course, just now the ball example, whatever I have considered, acceleration due to gravity, upward direction, downward direction, two different directions we are considering. So it is a vector quantity. So this is also true. Average speed is a vector quantity. Okay. Speed has only magnitude but no direction. So speed is a scalar quantity but not a vector quantity. This is a wrong statement. And next was displacement is a vector quantity. Yes, children, in the previous concept you already studied that displacement is nothing but the shortest distance. Many paths are there, among that only one path, the line joining from initial position to final position is called as a displacement. So it has some unique direction. So displacement is a vector quantity. You are asked to find the wrong statement. So which among them is the wrong statement? Third option is the wrong statement. So moving ahead. Next question, meter per second square is the unit of, yes children, earlier I told you that acceleration is defined as change in velocity upon time. Acceleration is nothing but change in velocity upon time. So change in velocity nothing but magnitude, or if you consider only that part, what is the physical quantity here? It is representing velocity, whether it is change or constant, whatever it is nothing but velocity only. Okay, you have to consider the unit for velocity. What is that? Meter per second. Unit for velocity, what you need to consider is upward. Numerator indicates the which physical quantity? Velocity. So we have units for acceleration is in SI units. If you consider velocity, which physical quantity? Velocity. Velocity means meter per second upon time, again second. So this is nothing but if you bring second downwards, it will be meter per second. Second will become second square. SI units of acceleration is meter per second square, whereas CGS units of acceleration is, instead of meter you consider it as centimeter, and here as usual second square. So remember children, SI unit of acceleration is meter per second square, whereas CGS unit of acceleration is centimeter per second square. Well, so meter per second square is the unit of what? Yes, it is acceleration. It's nothing but change in velocity by time, or another words, rate of change in velocity or change in velocity by time, both are same. Hence, rate of change of velocity is also true. Children, I told you that the negative acceleration is nothing but retardation. Only minus and plus symbol varies, but unit never varies. If that happens to be 5 meter per second square, this happens to be minus 5 meter per second square. If acceleration is 10 meter per second square, retardation is minus 10 meter per second square. Only symbol changes, but not the unit. Hence, retardation is also true. So all the three are true. Hence, meter per second square is the unit of retardation, acceleration, as well as rate of change of velocity. Hence, all the above statements are true. Hence, option number 4 is true. Moving ahead, a rubber ball dropped from certain height. So, earlier I told you an example of a ball thrown upwards. Now, the ball is dropped downwards. Whenever the rubber ball is dropped from certain height, it is an example of uniform acceleration. Children, as it is pulling, remember that as long as the acceleration due to gravity on the center of the earth is 0, okay, on the surface of the earth is maximum. So as and when we move away from the center of the earth towards space, the acceleration decreases because space is large, distance is large. So means here on the surface of the earth it has maximum acceleration. As long as we move away from the surface of the earth, acceleration due to gravity decreases. Similarly, as long as we go deeper inside the earth, again the gravitational pull decreases, acceleration due to gravity decreases. It will be maximum on the surface of the earth, decreases as we move above or decreases as we move below from the surface of the earth. So what they said is a rubber ball dropped from a certain height is an example of uniform acceleration. See, on the surface of the earth and certain height. As I said that acceleration on the surface of the earth is larger. So here it will be lesser. That means as and when the body is coming down, it is more attracted by the earth's surface. So it is accelerating. Okay. Away from the earth, decelerating. Towards the earth, accelerating. Attraction, more attracting power. So what they are saying is a rubber ball dropped from certain height is an example of uniform accelerating. More and more force is acting. So is an example of uniform acceleration. Your first option. Next. If the velocity of a body does not change, its acceleration is velocity, no change in velocity. What we said was acceleration is nothing but change in velocity upon time. Remember children, change in velocity upon time. But what they said was this change in velocity, no change means this is 0. change in velocity is not there. So the value of change in velocity is 0 upon some time t. 0 by anything is how much, children? 0. Okay. So acceleration is 0. So what they are saying, if the velocity of a body does not change, its acceleration will be 0. So first option. Next, the ratio of SI unit to CGS unit of retardation, whether it happens to be acceleration or retardation, units are meter per second. Yes, SI unit if you consider, I told you that it is meter per second square. What was that, children? So let us take it back. Yes. SI units is meter per second square, whereas AGS unit is centimeter per second square. Okay, so SI unit is meter per second square, whereas CGS units is centimeter per second square. You are asked to find the ratio of SI unit to CGS unit. SI unit to CGS unit ratio. Need to divide this. SI unit, how much, children? This is meter per second square by centimeter per second square. Both denominators are same, so cancel them. What you are left with? Numerator it is meters, denominator it is centimeter. So convert meter into centimeters. 1 meter is 100 centimeter upon centimeter. Again, so same units means what is the value? 100. 100 can also be written as 10 square. So your option is second option, 10 square. Next, when the distance of an object traveled is directly proportional to the length of the time. Length, it's not length, length of time they have mentioned. Length of how much time. So what they said is distance is proportional to time. It is said to travel with, is it zero velocity, constant speed, constant acceleration, or none? Children, we know that speed is equals to distance by time. Distance, they said? Distance. Okay, speed is equals to distance by time. Or distance is equals to speed into time. Distance is equals to speed into time. But what they said was distance is proportional to time. So what happens to velocity? Velocity is always constant. As long as the time increases, speed also increases. Then velocity, no change. So it is constant. So what is that? No, speed. Speed equals to distance by time. So speed is, V means speed. Speed is constant. So constant speed. When the distance of an object is traveled is directly proportional to the length of the time, then we say that it is moving with constant speed. Okay, because as t increases, speed, distance also increases. Hence, V remains constant. V indicates speed. Here, V indicates speed. Don't confuse. S means distance, V means speed, T means time. Next, a body has an acceleration of minus 4 meter per second square. If acceleration is equals to minus 4 meter per second square, what is its retardation? I told you, children, retardation is nothing but negative of acceleration. So this was given as acceleration. Okay, but what you're asked to find out is all regarding retardation. Retardation is nothing but negative of acceleration. If acceleration is indicated as A, then retardation is indicated as minus A. What is minus A, children? A was given as minus 4 meter per second square. So minus A is nothing but minus of minus 4 meter per second square. How much is that? 4 meter per second square. So it can also be written as, whether you indicate plus or do not write means the same. So 4, this can also be written as meter second square above. If you would like to write, it can also be written as S inverse 2. By S square can also be written as S inverse 2. So 4 meter per second square. So second option is the correct answer. Moving ahead, statement problem. A body may have acceleration even when its velocity is 0. Is it possible, children? So given that velocity is 0, so still a body have acceleration or not? Yes, of course it is possible. For example, uniform circular motion you can consider. Okay, so body may have acceleration even when its velocity is 0. Well, yes children, it is possible children. Acceleration, body can have still acceleration. Best example for this is the ball thrown upwards. Whenever the ball was thrown upwards at the highest point, what was its velocity? 0. But still acceleration due to gravity acts on it. So 0 velocity, but acceleration due to gravity is not 0. So statement 1 is true. A body can have acceleration even when the velocity is 0. So statement 1 is true. Moving to the statement 2, acceleration is the rate of change of velocity. The definition itself says that acceleration is rate of change of velocity. So statement 2 is also true. So you need to check out which statement is true. Both the statements are true? Yes, of course, both the statements are true. So your correct option is first one. So no need to bother about the other. Both the statements are true. Moving ahead, the next question. If the velocity of a body is decreasing with respect to time, velocity is decreasing, that means retardation. Increasing velocity means acceleration, decreasing velocity means retardation. Okay, increasing velocity means positive, decreasing velocity means negative. Okay, so the acceleration is said to be, no doubt it is negative. Decreasing, retardation, deceleration, negative acceleration, all means the same. Hence, if the velocity of a body is decreasing with respect to time, then that acceleration is always negative. Okay, children? So, next. Lata said to Lavanya, there are two persons, two friends, one name is Lata, the other name is Lavanya. So Lata is saying to Lavanya, acceleration due to gravity on the Hyderabad is same on the planet moon. Whereas Lavanya says that acceleration of the due to gravity at Hyderabad is different, moon is different. So let us try to understand this, children. Children, you need to know one thing, that the acceleration due to gravity on the surface of the earth is around 9.8 meter per second square. On the surface of the earth, the value is how much? 9.8 meter per second square. Whereas on the surface of the moon, it was found that it is 1/6 of what it is on the earth, 1/6 of g. That is nothing but 9.8 by 6 meter per second square. So children, how much would be this? 616, 1.6, 3, something like this. So what is the value of acceleration due to gravity on the surface of the moon? Something like 1.63 meter per second square. Whereas on the earth it is 9.8 meter per second square. So Lata said to Lavanya that acceleration, who is saying here? Lata is saying. Lata said. What was Lata's statement? Acceleration due to gravity on the Hyderabad. Earth. Hyderabad is also on the surface of the earth only. So on the earth. Okay, Hyderabad is same on the planet moon. Is it true? Earth means Hyderabad is 9.8, whereas moon is something 1.63. Are they both same? No. So Lata's statement was wrong. Whereas moving ahead, Lavanya said to Lata. So now Lavanya's statement. So what was Lavanya saying? So Lavanya, where is she? Yes. Lavanya says to Lata that acceleration due to gravity on Hyderabad, that is on earth, Hyderabad, is different from the planet moon. Yes, of course, true. Because here it is 9.8, here it is 1.63. So both are different. Yes. So what Lavanya said was absolutely true. Different. Then who is correct? Who is correct? Only Lavanya is correct, or both are correct? Or both are wrong? Only Lavanya is true. So 13th, first option. Only Lavanya's statement is true, that on the surface of the earth, that is at Hyderabad, you have different acceleration due to gravity, whereas at moon, you have different acceleration due to gravity. Next. Statement numerical problems. The value of g is minus 9.8 meter per second square if a body falls towards earth. and the value of G is plus 9.8 meter per second square if the body rises vertically up. Earlier I told you that acceleration due to gravity is maximum on the surface of the earth. As the body is approaching the earth, its value increases. Okay, acceleration due to gravity value increases. Hence, the increasing value is taken as plus 9.8. The value of G 9.8 if the body rises upwards. No, if it is coming down, then it is 9.8. But here vertically upwards means it should be minus 9.8. First, this statement is true. Other one, the value of G is minus 9.8 if a body falls towards the earth. Okay. Towards the earth means, just now I told you that it should be increasing. Increasing means positive. Plus 9.8. But what they have given here is minus 9 points. So both statements are false. Statement 1 is wrong, whereas statement 2 is also wrong. So your option number 2. Statement 1 is wrong. Statement 2 is also wrong. Moving ahead. Now, okay children. So that's all for today. Let us conclude here, and we shall move to the next topic, that is worksheet number 5 and some numericals regarding the equations of the motion in the next class. So that's all for today. So have a good day. Thank you children. Thank you.